Section 4.1, Introduction to Systems of Linear Equations, Solving by Graphing. A system of linear equations is a group of two or more equations solved simultaneously. Simultaneously means at the same time. A solution of a system of two linear equations in two variables is an ordered pair of numbers. Remember, an ordered pair will be two numbers representing x and y that make both equations in the system true. So the ordered pair has to make both equations true. Is 2, 3 a solution to this system? We have two equations in this system. We have x plus 2y equals 8, and we also have x minus y equals 2. So if 2, 3 is a solution to the system, then when we substitute it into both equations, it has to make both of them true. So let's substitute x equals 2 and y equals 3 into our first equation. That gives us 2 plus 3 times 2. Does that equal 8? 2 plus 6, yes, that's 8. That works. What about x minus y? 2 minus 3. Does that equal 2? No, it does not. So 2, 3 is not a solution to the system. It is a solution to the first equation in the system, but not the second one. And in order for it to be a solution to the system, it has to be a solution to both equations. Let's try 4, 2. If we substitute x equals 4 and y equals 2 into our first equation, we get 4 plus 2 times 2. Does that equal 8? 4 plus 2 is 8? Yes, that's true. What about x minus y? 4 minus 2. Does that equal 2? Yes, it does. So 4, 2 is a solution to the system because it is a solution to both equations. We can find the solution to a system in different ways. The first way we are going to find the solution to a system is by graphing. We have two lines here. We have x minus 2y equals 4, and we have 3x plus y equals 5. We're going to graph both of these lines. They're both written in general form, and when lines are written in general form, I like to solve them using the x and the y-intercept. If x is 0, that gives us negative 2y equals 4, so y is a negative 2. If y is 0, that gives us x equals 4. So we have two intercepts. We have 0, negative 2, and we have 4, 0. There's our line. Our second line, 3x plus y equals 5. We'll try to solve this or graph this by using the intercepts. If x is 0, that's easy. Then y is 5. But if y is 0, we get 3x equals 5. Divide both sides by 3. And we get x is 5/3. I'm not really looking forward to graphing that. Can we think of another point that represents a solution to this equation? There are an infinite number of points that work, but can you think of one? If you let x be 1, that would give us 3 plus 2 equals 5. So let's plot 0, 5, and 1, 2. Let's put those in a straight line and then look to see where those two lines cross. Because the point where those two lines cross, that point of 2, negative 1, that point is a solution to both equations. So it's a solution to the system. we have to graph both lines. We have to look at the point where they cross, and we have to write the coordinates of that point. Solve by graphing. Y equals 1/2 x minus 1. Y equals 1/2 x plus 2. Two lines. Both lines are in slope-intercept form, so I would like to graph them using the y-intercept, 0, -1, and the slope, 1/2. That's a positive 1/2, so the line will be going uphill. 0, -1, up 1 over 2. So that's our first line. Y equals 1/2 x plus 2 has a y-intercept of 0, 2. This slope is a positive 1/2. It's positive, so it's going uphill. 0, 2. Up 1 over 2. Up 1 over 2. Did you notice that both of these lines have a slope of 1/2? What does it mean when two lines have the same slope? These lines are parallel. So if the solution of a system of equations is the point that makes both of the lines true at the same time, the point that the lines have in common, the point where they intersect, that means this system has no solution. If two lines are parallel, they have no point in common. They have no solution in common. There is no solution to this system. What about 2x plus 4y equals -8 and 3x minus 6y equals 12? Both of these are in general form, and I like to solve equations in general form using the intercepts. Let's let x be 0 for our first equation. If x is 0, that gives us 4y equals -8. Divide both sides by 4. You get y is -2. Suppose we let y be 0. That'll give us 2x equals -8. Divide both sides by 2. We get -4. So 0, -2, and -4, 0. What about our second line? Let's do the same thing for it. Let's let x be 0. That gives us -6y equals 12. Divide both sides by -6. We get -2. Let's let y be 0. -3x equals 12. Divide both sides by -3. And we get -4. Wait a minute. Look at these points. Look at these points. What is going on? Let's plot those points. 0, -2 is right on top of the 0, -2 we plotted before. -4, 0, same point. So of course, when we graph that line, we find out it's the same line. They both represent the same line. Our solution to a system of equations is the point that those lines have in common. But these two lines are the same, so they have all points in common. How many points are on a line? There's an infinite number of points on a line. So there are infinitely many solutions. So every point on the line is a solution to the equation. To solve a system of linear equations by graphing, there are three possibilities. If the lines intersect, then the solution is an ordered pair of coordinates for the point of the intersection. Check that these coordinates satisfy both equations. If the lines are parallel, that means there is no solution. If the lines coincide, in other words, one is right on top of the other, it's the same line, then there are infinitely many solutions. All the ordered pairs of coordinates that represent points on the line. Each one is a solution. So what kinds of problems do we apply linear systems of linear equations to? You might have a problem such as a computer and printer combination sells for $1,200. The computer cost $400 more than the printer. If C represents the cost of the computer and P represents the cost of the printer, express the given information as a system of equations. Our first sentence says a computer and printer combination sells for $1,200. The computer plus the printer sells for $1,200. Our second sentence says that the computer costs, so the computer it costs $400 more than means add, $400 more than the printer. That's it. That's our two equations. A computer and printer combination sells for $1,200. The computer costs $400 more than the printer. That's it. On a coordinate plane, graph the system found in Part A. We're going to graph these two lines in the coordinate system, so we need to decide what our scale will be, and we also need to decide which axis is the c-axis and which axis is the p-axis. It doesn't really matter in this case. I'm going to put c here and p here. The reason I'm putting that c there and the p there is because we have c equals p plus 400. That equation is in slope-intercept form, and usually we have y equals mx plus b, so I want to put c equals p plus 400, so c will be on the vertical axis and p will be on the horizontal. Then we know that we have, if p is 0, we know that c will be 400. That's the c-intercept. And we could let c be 0. Then p would be negative 400. We're in the first quadrant. That's not going to be very helpful. We need another point. How about if we let p be 100, then c will be 500. That seems like a better point to me. Our other line is c plus p equals 1200. We can graph this using, it's in general form, so we can use our c and p intercept. If we let c be 0, p is 1200. If we let p be 0, c is 1200. So let's plot these points we know that we need for our c and our p values to go up to at least 1200. Let's count how many blocks there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 blocks, so we could let each block represent 100. So that puts us at 200, 400, 600, 800, 1,000, 1,200. We can do the same thing on the c-axis. We'll have 200, 400, 600, 800, 1,000, 1,200. So our first line here, C plus P equals 1,200. It has a p-intercept at 1,200 and a c-intercept at 1,200. That's C plus P equals 1,200. What about C equals P plus 400? We have the point 0, 400, and then we have the point 100, 500. So that's our second line. Where do they cross? I believe they cross at the point 400, 800. That's the solution. That's the point that they have in common. So the printer costs 400 and the computer costs 800. Altogether, they add up to $1,200. That makes sense. A computer and printer combination sells for $1,200. And the computer cost 400 more than the printer. Yes, it does. The computer cost 400 more than the printer. What's the significance of the coordinates of the point of intersection? It is really the only point that solves both equations. It makes both of those true statements. You must decide between two cell phone plans. Plan A charges a flat monthly fee of $120. Plan B charges $30 per month plus 5 cents per minute of use. Express the monthly bill Y in terms of the number of minutes X of use for each plan. So we have Plan A and we have Plan B. Plan A, the bill will be a flat monthly fee of $120. Doesn't matter how many minutes you talk. Plan B, the bill will be $30 plus 5 cents, 0.05, 5 cents per minute of use. Those are our two cell phone plans. Draw a graph that shows how the monthly bill relates to the minutes used for each plan. So Y is the amount of the bill. It's going to be in dollars. We know, based upon Plan A, that we need for Y to go up to at least $120. Once again, there are 12 blocks, so we can let each block stand for 10. So we have $20, $40, 60, 80, 100, and 120. Number of minutes. We need to decide what the scale should be on the x-axis. On Plan A, you don't care how many minutes you talk because you pay a flat fee of $120. So really, if we're thinking about number of minutes, we need to think about Plan B. Let's let x be 200. If you talk for 200 minutes, you will pay 200 times 0.05. That's 10 plus 30. You're going to pay $40. If you talk 1,000 minutes, you will pay 0.05 times 1,000 is 50 plus 30. You'll pay $80. So I think a scale that's appropriate for the x-axis would be, let's let every block be 200 minutes. So 200, 400, 600, 800, 1,000, 1,200, 1,400, 1,600, 1,800, 2,000. All right, so let's plot our points. 240, 1,000, 80, draw our line. What about, that's line B, that's plan B. What about plan A? Plan A is y equals 120. It does not matter how many minutes you talk. So plan A is horizontal, right at y equals 120. So where do these two plans have the same charge? This point looks to be 1,800, 120. So if you talk, for how many minutes do the two plans charge the same amount? For 1,800 minutes. Both plans charge $120. Hope you can see that's a 1 there. $120. If you spend about 3 hours per day on the phone, which plan is better? 3 hours? Well, I don't want hours, I want minutes. So how do I change hours to minutes? Multiply by 60. That's 180 minutes. But that's just for one day. I'm going to be talking on the phone. I'm going to be talking weekdays. So weekdays would be 5. So that would be 900 minutes a week. 3 hours per day, just for 5 days a week. Weekends are free. So 900 minutes, about right here. How much are we going to pay? About $70. So plan B will pay $70. And we know that plan A is always $120. So which plan is better? I think plan B. Odd Track Incorporated is planning to make a new kind of radio. Fixed cost will be $900 a month, and it will cost $15 to produce each radio. Each radio sells for about $30. Find the revenue formula, where A is the amount of money taken in, and X is the amount of money X is the number of radios the company sells in a month. So find the revenue formula. You're going to sell, A is the amount of money we're taking in, and we're going to sell the radios for $30 for each radio that we sell. So our horizontal axis will be X, our vertical axis will be A. Find the cost formula, where A is the monthly cost, and X is the number of the radios the company makes in a month. So how much is it going to cost? Well, we have fixed cost. That's $9,000. That doesn't depend upon how many radios we have to make. And fixed cost would be things like insurance payments, the electricity, the rent. It doesn't matter how many radios we make. But it costs $15 for each radio that we make. So we have our fixed cost of $9,000 plus 15 times each radio that we make. So what should our scales be here? Well, we know that A has to go up to at least 9,000. So why don't we make it 2,000, 4,000. Let's let every block be 2,000. 6,000, 8,000, 9,000, or 10,000, 12,000, 14,000, 16,000, 18,000, 20,000, 22,000, 24,000. How many radios are we going to make and sell? Let's say that each block represents 100. So 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. Sometimes you try one scale and it doesn't work, and you have to back up and try again. So, let's see, we have two equations to write. The first one is a equals 30x. That's really telling us that the y-intercept is 0 and the slope is 30, or the a-intercept in this case. But you can't just count up 30 blocks and over 1, because if you're going up, every block represents $2,000. If you're going right, every block represents 100 radios. When the scale is different on the x and y axis, you cannot count up and over the way we have been with slope. What you have to do is plot points. So if x is 0, we know that if we sell 0 radios, we're going to make $0. If x is 500, if we make and sell 500 radios, each one will sell for $30. So what is 30 times 500? 15,000. So 0, 0, 500, 15,000. That's sort of a straight line. What about our second equation? I need to plot some points for that one too. I know that if x is 0, y, or in this case, a, is $9,000. So 0, 9,000. If x is 500, we have 500 times 15 plus $9,000, $16,500. So 500, $16,500. Boy, these numbers are so large. Yeah, I've got to figure out where these two lines cross. That's not going to be easy to do. I'm going to have to just guess. Well, it looks to me like, I really don't know, like 650 radios maybe? And how much money are we making then? About 20,000? But that's just a guess. When your numbers are so big, it's hard to look at the graph and tell exactly what the answer is. We're going to guess it's going to break even where the revenues equal the cost. It's going to break even at $650, $20,000. But I'll be honest with you, I have no idea if that's right. I think the graphing method is kind of difficult to answer questions with when the numbers are so huge, or even when they're fractions, it's hard to tell where the answer is. So we need another method. Let's go find another method.